From that logic, we could say that minus 23 plus 0 will give us what? Minus 23. You agree, Abby? 0 now in modulo 6 would be 6, because 6 divided by 6 will give us 1 remainder 1. It could be 12, because 12 divided by 6 will give us 2. Hello and welcome, my excellent students. In this video, we'll be looking at subtraction in modular arithmetic. But as it is our usual practice, we start off by taking the solution to the previous take-home assignment. The questions were: question 1, to find, and secondly, construct addition table for modulo 4. Solution: 73 plus 89 would give us 73 plus 89 will give us 162, but it's not a valid residue in modulo 8 because modulo 8 residue is 0 to 7. So we do 162 divided by 8, and that will give us 20, remainder 2. So 73 plus 89 will give us 2 in modulo 8. 3 plus 8 in modulo 6. 3 plus 8 will give us 11, but in modulo 6, 11 is not a valid residue. The possible residues in modulo 6 are 0 to 5. So 11 divided by 6 will give us 1 remainder 5. And therefore 3 plus 8 in modulo 6 will give us 5. Question C, 5 plus 11 in modulus 4. 5 plus 11 will give us 16. 16 is not a valid modulus 4 residue. So valid modulus 4 residue is 0, 1, 2, and 3. To get this, we do 16 divided by 14. That will give us 4 remainder 0. So therefore 5 plus 11 in modulus 4 is 0. We first have to write residue to modulus 4, and that's 0, 1, 2, 3. So write it 0, 1, 2, 3. On this side 0, 1, 2, 3. We'll add all of this one by 1. So 0 plus 0 will give us 0. Since it's a valid residue of modulus 4, we'll give it 0 plus 1, 1, 0 plus 2, 2, 0 plus 3, 3. 1 plus 0, 1. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. So we do 4 divided by 4. That will give us 1 remainder 0. Because 4 is not a valid residue, so we have to divide it by the mode we are working with. So 2 plus 0, 2. 2 plus 1, 3. 2 plus 2, 4. So instead of 4, we write 0. And then 2 plus 3, 5. So 5 divided by 4 will give us 1 remainder. So we write 1. 3 plus 0, 3. 3 plus 1, 4. 3 plus 1 is 4. So we can't write 4, so we write 0. Because 4 divided by 4 will give us 1 remainder 0. 3 plus 2, 5. 5 divided by 4, 1 remainder 1, so we write 1. And 3 plus 3, 6. 6 divided by 4 will give us 1 remainder 2, so we write 2. Subtraction, modular arithmetic. Examples. Reduce to its simplest form. A minus 23 in modulo 6. B minus 57 in modulo 9. Question 2. Find 7 minus 4 in mod 3. B 51 minus 82 in mod 9. Prepare subtraction operation table for modulo 5. 1. We ask to reduce minus 23 to modulo 6. One thing that I want you to understand in modulo, in any modulo is equal to the value of that modulo. And you see this from the examples that I've done. You see here that in mode 4, when we got 4 was what? 0, because it will give us remainder 0. So from that logic, we could say that minus 23 plus 0 will give us what? Minus 23. You agree, Abby? Fine. 0 now in modulo 6 would be 6, because 6 divided by 6 will give us one remainder 1. It could be 12, because 12 divided by 6 will give us 2 remainder 0, and which will still be 0 in this modulo. Do you understand? So basically, zeros could be multiples of the modulo you're working with. It could be 6, it could be 12, it could be 18, it could be 24. For us to get our final answer for this question, or for questions like this, we need to get the multiple of the modulo we are working with that is greater than that negative value. In this case, 24 is greater than 23, and 24 in modulo 6, 24 in modulo 6 is 0, right? So it means that if we say minus 23 plus 0, we can still write it as minus 23 plus 24, because 24 in modulo 6 is 0. And so this one will give us minus 23 plus 24, that's what? 1 in modulo 6. So that means minus 23 in modulo 6 is 1 in modulo 6, basically. Now, let me quickly explain this concept of minus 23 plus 4. If I say 24 minus 23, I'm sure everybody would understand that the answer is 1. But minus 23 plus 4, how is it 1? It's still the same thing. It's just me rearranging this, bringing the 24 outside and minus 23 inside. Note that in mathematics, all number has a sign, and the sign is to the left hand side. So if I write 24, it means that there's an implicit sign which is plus that I did not show. Note that when you have negative, just assume that is a debt. So minus 23, you are owing me 23. Plus 24, plus is what you have available. You now have 24 available. If you pay that 24 from the 23 you are owing me, it will remain 1. Now that 1, will it be positive or negative? How you know is that whichever is greater, the positive value is greater than the negative value, so your final answer will be positive. That's like a shortcut. So if you have plus 5 minus 7, for example, I told you that each number has a sign and the sign is in front or by the left hand side. So the sign of 7 is this minus, and the sign of 5 is this plus. This plus could be written and sometimes might not be written. So that means this is the same thing as saying 5 minus 7. Just know that there's an implicit plus sign here, even when it's not written. So back to what we were saying. Which is greater number? 7 is greater than 5. And the greater number 7 has the negative. That means our answer will also be negative. So 7 minus 5 will now be what? Minus 2. So that is a shortcut, because I find a lot of students struggle with this particular concept. First is to assume that the negative is what you are owing and then the positive is what you have. And so when you pay what you have from what you are owing, what will be left? If the greater number is positive, then your answer will be positive. If the greater number is negative, then your answer will be negative. That is just by the way. Back to our question, minus 23 modulo 6 will give us 1. 1b, minus 57 in modulo 9. So the idea is to add 0 to this, but note that in modulo 9, possible zeros are multiples of 9, like 9, 18, 27, 36, 45, 54, 63. Keep writing until you get a number that is greater than the negative that you are working with. I can confirm this. 9 divided by 9, because you are working with modulo 9, we are going to divide this by 9. 9 divided by 9 will give us 1 remainder 0. 18 divided by 9 will give us 2 remainder 0. 27 divided by 9 will give us 3 remainder 0. And on and on and on and on like that. 63 divided by 9 will give us 7 remainder 0. And because we are working with modular arithmetic, we are concerned with remainder, so this is practically 0. So if we say minus 57 plus 0, we can as well say is equivalent to minus 57 plus 63 in modulo 9. Which has the greater number? Positive 63, negative 57. So positive 63 is greater. So our answer will be positive. 63 minus 57, 6. So minus 57 is 6 in modulo 9. 7 minus 4 in mod 3. 7 minus 4 will give us 3. 3 is not a valid mod 3. In mod 3, the possible residues are 0, 1, and 2. So this 3 will become 3 divided by 3, and that's 1 remainder. 0. 7 minus 4 will give us 0 in modulo 3. It should be 51 minus 82. So from what I explained here, you see that this minus sign is for which number? Exactly for 82. And there's an implicit plus sign in front of 51. So of this now, 82 and 51, which is the greater number? 82 is the greater number. And 82 has a what? Negative sign. That means our answer will also be what? Negative. 82 minus 51, 31 in modulo 9. Minus 31 in modulo 9. How do we do that? We just say minus 31 plus 0. But the values of 0 in mod 9 are multiples of 0, just like we did here. It could be 9, it could be 18, it could be 27, it could be 36. So we'll pick 36 because 36 is the closest positive number to the number we're working with, which is minus 31. So minus 31 plus 0 in mod 9 is the same thing as saying minus 31 plus 36, because 36 in mod 9 will give us 4 remainder 0, which is 0 in mod 9. 36 is the greater number and it has the positive sign, so our answer will be positive. 36 minus 31 will give us 5. So we say 51 minus 82 is 5 in modulo 9. Draw a subtraction table for modulo 5. The first thing we want to do is to write the residues in this modulo. In modulo 5, the residues are 0, 1, 2, 3, 4. You can draw a table 0, 1, 2, 3, 4. First here we write the operation we are working with, which is subtraction operation. 2, 1, 2, 3, 4. Subtracting one after the other. 0 minus 0 is 0. 0 minus 1. 0 minus 1 is minus 1. So we have to do 0 in the mode we are working with, which is mode 5. The closest 0 to minus 1 is 5. So we can say 5 minus 1, that's 4. So 0 minus 2 plus 0. That's minus 2 plus 5, because in modulus 5, 0 is 5, and this will give us 3. 0 minus 3, that would be minus 3. 0 is 5 in modulus 5. Then that's 2. 0 minus 4, minus 4. That's minus 4 plus 5, and that will give us 1. 1 minus 0, 1. 1 minus 1, 0. 1 minus 2, that's minus 1. And minus 1 is 4 in this modulo. Then 1 minus 3 is minus 2. So minus 2 in this modulo, we can add 0 to it, right? So 0 in modulus 5 is plus 5. 5 minus 2 will give us 3. 1 minus 4 is minus 3. And minus 3 plus 0 is minus 3 plus 5 in modulus 5. And that will give us 2. 2 minus 0 is 2. 2 minus 1 is 1. 2 minus 2 is 0. So 2 minus 3 is minus 1. 2 minus 3, you remember, higher number is negative, so the answer will be minus 1 negative. Now minus 1 in modulus 5 is 4. So 2 minus 4, 2 minus 4 is minus 2. So minus 2 plus 0, 0 in modulus 5 is 5. Minus 2 plus 5 will give us 3. 3 minus 0, 3. 3 minus 1, 2. 3 minus 2, 1. 3 minus 3, 0. 3 minus 4, minus 1. Minus 1 is plus 4 here. 4 minus 0, 4. 4 minus 1, 3. 4 minus 2, 2. 4 minus 3, 1. 4 minus 4, 0. Let's take the take-home question for this concept. Question 1. Reduce to its simplest form. A -7 in modulus 9. B -13 in modulus 5. Question 2. Solve 28 -45 in modulus 7. B 9 -8 in modulus 6. Question 3. Construct subtraction table for module 3. I hope you understand everything we have said in this video, and I hope you enjoyed the video as much as I enjoyed explaining it. Remember, if it didn't make sense the first time, watch it again. That is the MathSense way. I will see you in the next video.